Hey guys, Mr. Bowman here. Today's linear objective is in blue and we are learning to use trigonometry to solve problems from context. So before we start, this idea of context, this just means kind of like real world examples. So when you see that word context, it relates to a given scenario. And I've actually got some here. We actually see right angles quite a bit in the real world. For example, the corner of any football pitch, any sports pitch really, is always a right angle. In construction, you see some doorways set up here. That angle between the ground and the right-hand side of the door is a right angle as well. And this here, we've got a kind of a ladder scenario as well. So when you put a ladder against a wall, the corner on the bottom always forms a right angle. So this idea of right angles, they're there everywhere in the real world. And sometimes you're going to need to know how to use trigonometry to find out these scenarios. So just to recap our steps for trigonometry, the first step you always have to do is you've got to label your triangle. So there's no avoiding that. And once you've labeled your triangle, you then have to pick your formula. And that's based on what sides of the triangle are relevant. And third step, you have to substitute. So all the relevant values you've got to put into that formula that you picked above. And finally, once you've done that, you can go ahead and solve. When you're dealing with context, there's actually going to be a step, we'll call it maybe step 0 sitting before it. You're going to have to draw your triangle. So sometimes the triangle is not always obvious, and we're going to go through 1 or 2 questions to highlight this for you. Okay, so I've got a question on the board. A ladder resting against a wall, so it relates to this ladder scenario down here, forms a right angle triangle. If you have a 10-meter ladder rising at 60 degrees, so 10 meters and 60 degrees, how far up the wall does the ladder reach? First step, we don't have a triangle this time around. Normally we're given the triangle, this time around we don't have it. So we're going to have to draw a triangle. So what I'm going to do is I'm just going to draw a random right angle triangle and going up like this, and there's the right angle that sits along the base. What that means is this bottom bit here, that's the ground. This here, that's probably the wall, and the one going up on the angle, that's always going to be the ladder. So that's just linking my triangle to the scenario we're looking at. Once I've done that, I've now got to start adding in my numbers, and I've got to figure out what I'm trying to calculate. So if you have a 10-meter ladder, so that one's fairly straightforward. We know this ladder side, well, that ladder is 10 meters long, and it's been stretched, sitting on the ground, and it's going all the way up to the wall there. It's rising at 60 degrees. So rising normally means the increasing one, so that's probably going to be this angle down the bottom. So that there is 60 degrees. And then finally, how far up the wall does the ladder reach? So it looks like we're interested in the wall, or how far it goes from the ground to the top. So let's call this side of the triangle X. That means we're not really interested in how far it is away from the ground. So we've drawn our triangle, that's our first step. And now we're going to get into our usual 4-step process for trigonometry. We're going to label our sides. We've got our hypotenuse over here, we've got our opposite over here, and we've got our adjacent over here. As I said before, we don't care about the adjacent. That means we're left with O and H, which is the, if you think of our SOHCAHTOA, that's going to be the SOH formula. So we're dealing with sine. So we've got sine angle equals O over H. We're then going to substitute. So we've labeled our triangle, we've picked our formula. We're now onto the substitution phase. We know that the angle is 60. So that's going to be sine 60 equals O is the X and H is the 10. And we're then going to use a bit of algebra here. So we're going to times both sides by 10. So 10 times sine 60 equals X. We're then going to grab out our calculator to figure out what X is and how far up the wall the ladder goes. So we've got 10 times sine 60. That's going to be 8.66 meters. and that there had a 2dp rounding. So guys, we've got a short video. Hopefully you saw the substitution happen. Hopefully you saw us solve to get our final answer. So just to recap, we're looking at questions involving context. And normally what happens is in context is the triangles aren't drawn or they're not obvious. And you've got to go through and draw the triangle yourself, just like we did in orange. Once you've done that, you can adopt your 4-step trigonometry process to go ahead and solve your problem. Thanks so much for watching, guys. Now let's get into some questions.